Our seminars and webinars disseminate outcomes of feasibility studies and academic consultancies that are undertaken by 7 Scottish universities in collaboration with small to medium-sized enterprises in Scotland. The project focuses on sustainable building design and refurbishment, and it is funded by European Regional Development Fund and CIC program of Scottish Government that is currently managed by Scottish Funding Council. This is a live event, so it might happen that there is a fire alarm. If it does happen, then we will have to stop and continue later, and you are welcome to join us. But if you are not able to join us, then you can watch a video recording of this webinar in a few days. We plan to finish the event around 2 o'clock, but you can start using the chat facility to ask questions, and these questions will be answered around 1:30. So we will have around 30 minutes for questions and answer session. If all questions are not answered by that time, they will be answered by email by our speakers today. So the title of today's webinar is a retrofit of an 18th century traditional Scottish house using the Passivhaus standard. This study was undertaken by Edinburgh Napier University in collaboration with SA Estates. And our speakers today are Julio Bros-Williamson of Edinburgh Napier University and John Stephen of SA Estates. I will now kindly ask Julio to start his presentation.
Thank you very much, Branka. I'd like to begin just by as always, thanking you and your team for the opportunity of working alongside SA Estates and John Stephen in this very kind of hot topic, both the standard itself and the whole retrofit idea of traditional buildings. As Branka just pointed out, this project deals with retrofit and implementing the Passivhaus standard. And the report really concentrates a lot on the benefits and the options around the planning of this type of standard and applied to current buildings and traditional buildings. Just as a kind of explanation of what we'll be talking about today, we'll have a brief introduction and just looking at the outcomes and the aim and objectives of the whole study that was completed. We will also be looking at explaining the existing building and the case study that's been part of this study on the existing elements of it. Then we would look into how to apply and all the criteria that the Passivhaus standard has and how that can be implemented into the current building in question. And then we'll round up with some conclusions, both from myself and also the client and SA Estates. So just as an introduction of who we are and the study itself, the study was done in conjunction with the Scottish Energy Centre, which is part of Edinburgh Napier University, and SA Estates. We are a consultancy-based office attached to the university, where we do research on sustainability, energy efficiency, etc. I'll briefly pass on to John Stephen from SA Estates to give a roundup of what he's involved in and the nature of his practice.
Thank you, Julio. Well, first of all, my background is architectural, having been in architectural practice for many years, but also attaching a development arm on which we largely concentrate now. We do development consultancy also, but it all does stem from our architectural background. We specialise in old buildings, restoration of old buildings of all shapes and sizes. This is quite a small project, but is quite significant in our terms as a development company, where for the first time we've really started to look at properly how we convert this building in terms of energy, sustainability, and the impact of those considerations on ultimately the use of the building and what effect that will have. This particular building is really a very typical Scottish house of about 250 years age. Over the years, and particularly in the last 50 years, it's been, one might argue, mutilated with attempts at conversion of one form or another. But that actually suits our approach because we regard the building that the raw ingredients are all there, but we can actually strip it back to its essential core and then refit it out with good practice as we see it. It does happen to be in the context of a two-house project, in that the garden ground to the rear and the north also has sufficient ground at the top to build a new house. Both of these houses will be intended for holiday homes, and that has a particular significance as well, in that the way holiday houses are used is different from normal housing accommodation, particularly in respect of energy, in as much as there's more wastage of energy when people are on holiday, interestingly. So that led to our connection with Julio and Napier University, in as much as we weren't experts. We had an awareness, obviously, as it's topical to be aware of energy considerations these days increasingly, and the cost of energy in parallel with that. But within our organisation, there's a genuine empathy with a balanced end product, and energy is a significant part of that. So we agreed with Julio to do this initial study to get on the right track and to gain a better understanding of the technical aspects and specifications that we would need to deploy to make this fit the bill and ultimately be sustainable in a rounded sense. Now, the slides that have come up, interestingly, that is actually not this building, but relates to a very similar project that we've actually completed, but was started and specified about 5 years ago. But it does show that there was an inherent aim and aspiration to combine the old with the new. And as they're of similar scale, I thought it would be interesting just to show this illustration. Both of these properties are in Fife on the east coast of Scotland. Scottish weather, for those that don't know Scotland so well, does vary, and we do get a lot of rain, but the east coast of Scotland actually gets quite a lot of sunshine, and this part of Scotland actually is one of the driest parts of our country. What we found when we have these small buildings, they are, and it's come out in the study, they're inherently difficult to retrofit to a passive house standards. But there is, if the opportunity avails, there is a potential to enhance that or overcome that difficulty if you have the ground and the facility and the money, of course, to build an extension and to incorporate some modern construction as a layer on top of the existing fabric. And that's what we did here, albeit it was more from gut empirical methods and experience rather than from an expertise and knowledge of energy considerations. And that's where I'd say it's been very useful to bring Julio and his team on board, who have that technical knowledge and a much greater depth of understanding of the problem. So this project here started to lay the groundwork for how we would tackle small buildings like this. And suffice to say that you can see there's quite a lot of glass. It's south-facing on that side, and it does two things. It without going into too much detail, it starts to create the right physical environment from an energy point of view, but it actually also adds to the living quality and the usage of the property at the end of the day, because you get the benefit of very good spaces from an internal perspective and a lot of light in the right part, and of course the passive solar gain comes on tap. And although the Celladite project, which is the focus of this discussion, already we can see the same ingredients where we would, in addition to trying to upgrade the existing fabric, we would combine that with a modern extension at the rear on the north side.
So just to go back to the case study that we're part of this report, the main brief of it was obviously to analyse Passivhaus standard, not the traditional Passivhaus standard that's been applied in a lot of new builds, but also extend it over to how it would be applied in a retrofit idea. And the Passivhaus Centre Institute has had an extensive set of guidelines dealing with current buildings and how to apply the standard onto it. So a lot of that information was taken on board for the production of this study. The possibilities and looking at the standard itself has been quite challenging, especially because we're dealing with a current building, and there's a lot of limitations that we'll explain later on. But I mean, the Passivhaus standard is mature enough. It's got at least 20 years of projects being developed in mainland Europe, and over the past 5-6 years, it's been quite strong in Scotland and the UK. So it was an interesting project for us to engage into the standard itself, but applied to retrofit. I mean, the main objective is really to create an outline and to evaluate the building and to see if it had potential for applying the Passivhaus standard. It won't be looking at the actual design of it, but there will be some aspects that we will try and apply and look at the pros and cons with the building in question. So there'll be many areas addressed within the building fabric and also the building services within the building, and obviously try and have as close as possible all the criteria that Passivhaus has. We will also be looking at ways to really have this report as a guide for SA estates to make a decision on whether this is the right path in taking the Passivhaus standard, or really going down a more traditional retrofit route that can apply similar standards or similar elements in the fabric, but just in a different mode. So it's creating that kind of debate on what the best alternative is for this building. As I've mentioned before, we're not looking at the actual design of it, but really looking at the planning side of things and the decision making on what route to take. And Passivhaus was the retrofit idea was a clear route and an interesting one to approach. John will now explain a bit about the existing building itself, just looking at the site and also the different elements within the existing building.
Okay, well, in this part of Scotland, the historic structure is solid stone walls with no cavities and an inner lining of plaster on a thin timber frame. The roof has no insulation whatsoever, so it's effectively a thin layer of timber on timber rafters with clay pantiles on top, so a lot of heat loss. It has had, in inverted commas, modern refurbishment. The glazing is double glazed, but it's poor quality, probably 25 or more years old, and is a facsimile of traditional astragal windows, but doesn't actually achieve that objective really either. But again, the building from our point of view was such that we really see it as a shell. The internal partitioning is also relatively recent compared to the age of the building, and we see nothing precious that can't be removed if we decide to remove it. And in fact, partly as a result of the study, we would actually see ourselves stripping the interior of the existing building back to the bare stone walls inside, removing virtually all of the partitions and simply leaving the intermediate floors, which are timber, and going back to go forward, as it were. So that then does actually give us a fairly free rein internally, and we can apply retrospectively whatever level of specification and fit out as we wish. So this is a good opportunity to go as to the limits of trying to achieve actually passive certification standards. And that's possible, but it does come with some penalties. The biggest penalty in this case is the loss of space. It's actually quite a modestly sized house, and to add insulation, which might build up to as much as 250 millimeters of overall thickness, wrapping round the envelope, particularly the south and the north walls, which are external walls, and that's a consideration. But in our case, we feel that would be possible because we anticipate building a modern extension on the back. We've made that decision, therefore we will gain space, and we have a significant amount of ground in which to do that, so we can compensate for the loss of insulation loss space in that process. But that's only one consideration. The outer face of the external walls also requires consideration. In this case, the front wall, if we have a slide of the front elevation, that has had an over application of cosmetic render, which was fashionable 30 years ago when these works were done, but now is regarded as, if it can be removed, it's beneficial both from a visual point of view and in terms of fitting in with the rest of the traditional housing style of this area. Improvements can be made, and we would expect to find traditional stonework underneath. That in itself doesn't really afford an opportunity to improve the energy aspect of it, simply the visual side. On the north face, where we have the existing stone features, and again, perhaps if we can bring a slide up on that front, we see that being encapsulated within a two-story extension. So the staircase, which is seen in the back, will actually become an internal feature and will enhance the interior, and the modern construction can be specified as appropriate to passive house standards. Being north, it's unlikely to have much glass, but we will use the roof, which will be integrated into the traditional existing roof to potentially incorporate PV solar panels. As an alternative to putting solar panels either only on the roof or on the roof at all, we're actually envisaging building a solar greenhouse in the garden grounds. And I'm aware now that there are proprietary products available where you can literally buy a greenhouse and plant that in your garden. So we see that as an interesting adjunct to the design here too. We'll also consider ground source heat pumps as a means of providing heating, which would involve drilling down approximately 120 meters into the ground, which will be likely sandstone or sedimentary rocks, but we feel that would be feasible. So that a combination, effectively, of considerably improved insulation onto the existing fabric, together with PV and ground source heat pump technology, is how we foresee that we're going to move forwards. It has to be said, we're trying to pick buildings now which afford us the flexibility to apply the contemporary technology to these older properties. And I think that having the ability to put an extension on the back is a considerable advantage. It gives us a fighting chance of achieving that objective.
In terms of the methodology that we took for this report and this study, we really, as I mentioned before, taken the standard that the Passivhaus Institute has developed, looking at obviously the retrofit ideas and looking at how flexible that is to be applied in this building, in this particular building. So we did an assessment of the site, assessment of the building as much as possible. And then we started to look at the different criteria and looking at how the building fabric first would be adapted to this criteria, and also looking at all the alternatives for heating that could be implemented. In terms of the fabric elements, because there's different thermal performance criteria imposed, we did conduct some small simulations on different alternatives of wall build-ups and roofs, insulation, etc. Most of the elements were simulated and checked as well using different U-value calculators in order to achieve and reach the criteria. So that's really the approach towards the fabric. Just a small roundup of what the Passivhaus requirements are. I mean, as I've mentioned before, it's been implemented over the last 20 years. A Passivhaus really, or as the Institute refers it to, is a quality approved Passivhaus, highly energy efficient, looking at comfort levels, thermal comfort in a very focused way, and both indoor climate and space heating and cooling systems are implemented. Space heating is a big element, and obviously achieving space heating with minimal energy requirements, and as the name itself comes in, looking at it in a more passive way, in a more natural way. So that's the kind of area that the Passivhaus focuses on. Really, the objective of Passivhaus is to look at a combination of solar, passive solar and passive ventilation systems, together with internal gains to bring up these thermal comfort levels to high standards, and trying to minimise any active heating sources and use of energy. The Passivhaus is designed and calculated and used and evaluated, I would say, by a calculator and a spreadsheet that the Passivhaus designer would use, called the Passivhaus planning package, which really puts in a lot of the design inputs to work and tries to obtain very low space heating requirements, and really evaluates what the design is how it's going to be implemented. And with that, construction can take over, and a proper, more technical design can be implemented. So it's a very strict, very kind of wide standard. In order to really complete this report, we really had to strip down and obtain as much information from the Institute, from the Passivhaus Institute, and try and look at how the different stages of the design and the actual standard could be applied to this building. So we did a small kind of summary on the requirements. I would say this study really falls under these first two criteria of selecting and looking at the site planning, and also the pre-planning of the building and the actual design. So really it's just pointing out how this standard could be applied and what limitations there are. So site planning is important, looking at the site suitability, infrastructure around the building, planning permission that would need to be obtained by council areas, and just really looking at those elements. Then looking at the pre-planning, which really evaluates the building itself, which is part of the study, looking at how the different criteria can be applied, and in other circumstances, conducting a Passivhaus planning package calculation. And I mean, part of this would look at the building itself, looking at how south-facing elevations can be implemented for further design, looking at the envelope and the fabric itself, just evaluating what elements can be improved, focusing on thermal bridging, etc., etc. Looking at areas that are away from unheated spaces and how we can overcome those problems, and also looking at how we can prepare for this Passivhaus planning package in order to complete a more detailed design. The next stages, which are kind of recommended and should take over and continue from this report, are looking at planning and the Passivhaus certification, where the development of the design is taken in place in a bit more detail, and looking at specifications in a bit more focus on the different elements, and looking at services for the first time on how technology can be installed in this building. So that can be quite a challenge when you're dealing with a current building, with an existing shell, trying to adapt technology into the building itself. And then there's more specified and more detailed elements in the planning of the building, a bit more on the basic fabric and the different openings, whether they're doors, windows, etc., and looking at different Passivhaus insulation alternatives, glazing, etc., etc. And also the ventilation systems. Traditionally, most of the Passivhaus houses and buildings use an MVHR system, a kind of heating and ventilation technology, in order to obtain fresh air and take advantage of heat from other spaces and other rooms within the building. So that would be something to consider, definitely. Additional kind of building technology, looking at renewables, looking at how hot and cold water would be implemented in the building, and most importantly, how that pipework will be channeled and designed around the building. Obviously taking into consideration thermal bridging and air tightness within the building, which is very important in Passivhaus, and which can be very difficult in an existing shell, as opposed to new build Passivhouses that can be more detailed, and air tightness can be solved in a quicker phase. And that takes us on to the construction phase, again divided into the building fabric and the ventilation and the technology and the heating of that building. And as I've mentioned, cold bridging and air tightness being very important on site, and looking at the problems themselves and how the building fabric is existing, and obviously there's a lot of elements that have to be looked at. And then, I mean, looking at how more the construction phase and different renewables are installed onto the building, and how they can integrate, And the last point, really looking at how occupiers and the users of this building will be engaging within this new technology-based and highly insulated building. So how to really integrate the users and for them to understand this relatively complex building. I mean, some of the criteria that are focused and are very important in Passivhaus that we try to apply and try to really bring up to the standard that's required really looks at space heating demand and how all heating and active sources and how passive heating elements can be applied, and there's different standards to that, different calculations that are in place and different limitations. That obviously goes in hand with the heating load and the capacity of the systems and the amount of power that's required for them. Depending on location, not the case in this project, but cooling demand is also important, which is very similar to the space heating, but just different climate. Looking also at primary energy use, which includes heating, includes appliances, includes the use of electricity around the building, so how efficient the building can be. The air tightness of the building, which is really important and measured at 50 pascals. Looking also at U values, both on opaque surfaces and elements, for example, the walls, the ground floors, and also the windows and different openings. So that's important. I've mentioned thermal bridging, which is also a key point in Passivhaus, and limiting this thermal conductance through different structural components or wall elements. And the last point, looking at moisture protection and how well the building is sheltered and protected from any moisture and condensation. So this table really explains the different criteria that I've just mentioned and the different numbers really that are required to be fulfilled. I think that one of the most important ones is space heating demand and how the different elements should be, and the difference between new build and refurbished. And I mean, it's also important to look at the different air permeability standards as well. Looking at new build and in difference with the refurbishment, because it's a current building, the refurbishment standard is slightly more relaxed because we're dealing with an existing shell. So a contrast there between new and refurbished elements, and also the U values that do tend to be a bit more comprehensive on the building itself. So what we did then is look at this criteria and look at obviously applying it to the building itself. And I mentioned air tightness as being key to achieving and reducing the space heating demand within the building, and which obviously eventually will reduce a lot of CO2 and the use of heating devices. And that's really part of what Passivhaus is really important. So looking at elements like the chimney breast, how to obviously seal that and limit the amount of air escaping through that. Looking at areas like gaps and different cracks around the building fabric, service penetrations, the windows, how well they're fitted, etc., doors, etc. So air tightness being a big focus. It's estimated from previous case studies and other testing that the buildings of this nature have an air tightness, air permeability figure of between 16 and 20 meters cubed per meter squared hour. So that's an extortion. It's quite a big figure, really, compared to new builds and current standards. So obviously that is quite a priority in this case. So we looked at the different elements. For example, the walls, as John has explained, the front elevation has this mortar and this render that's known to be quite recent, within the last 5 years. It then follows on with around 500 millimeters of sandstone. And then there's 50 millimeters of a void, which is part of the timber studs, followed by plasterboard. And this gives us an estimated U value of 1.1. And then we looked at alternatives, looking at different ways of lowering that, and obviously trying to match it with as close as possible to the Passivhaus criteria. And we did that by adding insulation. In this case, we added 60 millimeters of wood fibre board as one of the alternatives, looking at a vapour control layer, and also increasing with 2 layers of 100 millimeters of sheep's wool, and then the same kind of plasterboard build-up as a finish. We did try and look at having service zones within the walls, so that any surfaces didn't perforate and penetrate the air tightness layers that could be designed for a wall of this system. So, I mean, by analysing it both in SciMap and U-value calculators, we did achieve a 0.15 U-value. Another alternative, using, I would say, different types of insulation. The previous one was looking at sheep's wool and more ecological materials. In this case, it's a more mainstream and man-made type insulation. And in the same way, we would apply this service zone, and also with 2 layers of plasterboard, of OSB, sorry, and then having phenolic insulation in between the different timber batons, and also on either side, in order to reduce any thermal bridging through the timber. So that was important, and then obviously the existing 500 millimeter sandstone rubble would follow that. So again, 2 alternatives that are very similar in their U value and close to, and obviously part of the Passivhaus standard. We also analysed the party walls. As was observed in some of the photographs, the building is sandwiched between 2 neighbours, between two existing buildings. So obviously it's unknown what the temperatures are on either side of the building. So it was kind of treated as an external wall, but really not as exposed as the 2 south and north elevations. So in this case, we looked at it being around 200 millimeter sandstone, with again timber studs in the inside, and plasterboard as a finish. And the alternative, really, to enhance it and to reduce the U value, we looked at again having this surface zone in the inside with 2 layers of OSB with timber studs, and applying 60 millimeters of wood fibre insulation that would lower that U value considerably, from 1.6 to 0.4. As again seen in that front elevation, there's a dormer window facing the main elevation and the main street at the front. And sadly, the dormer walls, or as best described as dormer cheeks, are not insulated at all at the moment, and really are just part of a traditional kind of timber wall, timber constructed wall, with an external finish of slate, with just timber studs and plasterboard interior. So we looked at different alternatives. Obviously, there's a reduced space in that dormer itself, so we looked at enhancing it with insulation, but trying to use thin solutions. So in this case, we looked at an alternative of installing 50 millimeters of rigid phenolic insulation between the batons, the original batons, and also applying a thin layer of aerogel, really just to lower as much as possible that U value in that reduced space. So that gave us, from a previous 1.75 watt U value to 0.4 again. In terms of the roof, as John mentioned, it's an uninsulated roof. It's limited in space and head height. The floor to ceiling or floor to joist, as can be seen in the photographs, is less than 2 meters. So it's limited really to the amount of insulation that can be applied to the original surfaces. But nevertheless, there is space behind the walls that can be seen in this photograph, and that can be accessible to enhance and to add insulation into really the surrounding void around that room, which is really that attic, converted attic. So we looked at in that existing ceiling to add 300 millimeters of sheep's wool, and which really is a small void just underneath the ridge of the roof. It's considerably small, but 300 millimeters there, and then on the sides of the roof and the different wall configurations around it, adding 100 millimeters of sheep's wool. And also in between the studs, 60 millimeters of wood fibre insulation. So that really came down to a U value of 0.1, which overall really in all the different wall and ceiling. So considerably low, and I think a good alternative in that case. In terms of the floor, the ground floor in this case, it's unfortunately, because it's quite a compact building and quite small in footprint, the head height and the floor to ceiling height in the ground floor is quite limited. At the moment, it's got just under 2.2 meters, just over 2 meters head height. So that really brought in complications in enhancing and adding insulation underneath the floor itself. Currently it has a stone, original stone floor and base. So really it was difficult to insulate, given that small height. So again, that's where we started to look at enhancing and adding insulation, was in that case quite a complicated task. But what we did look, and mainly for acoustic purposes, was that in the first floor and in the intermediate floor, to add 100 millimeters of sheep's wool insulation to really have this minimise any noise from up above it, but really more on the acoustic side. Windows and doors, again, as John has mentioned, it currently has PVC double glazed windows. It's obviously the inclusion and the installation of double glazed windows can be quite a costly work, and so this obviously, in order to obtain the Passivhaus standard, these windows would have to be replaced, sadly. Although they're still properly functioning double glazed windows, in order to fulfil the standard, they would have to be replaced to triple glazed windows. So we've suggested really to look at a more conventional timber framed set of windows with triple glazing, really to integrate with the context of the building and the surrounding, and bring it back to this original state, which, I mean, originally it must have had sash and case traditional windows. In terms of the doors, again, Passivhaus looks at Passivhaus certified products, and in most cases, super insulated doors are installed, and in this case, that would probably be the adequate route. But we would recommend and try and work with what is there already. So, for example, the front door, which is this yellow door in the third photograph, instead of replacing it, we would probably look at maybe enhancing it and using thin insulation materials to lower the U value of it. At the moment, it has a draft lobby, so we would suggest really to keep that, and in order to keep the internal temperatures as much as possible. In terms of the building services and the heating and ventilation, the use of MVHR is quite important in Passivhaus, because these buildings are very airtight. They do require mechanical ventilation and heat recovery. Anything below 5 or 3 meters cubed should require this mechanical ventilation in order to bring in fresh air into the building, and also mix it with the hot air that's produced in bathrooms and kitchens. So a whole duct system and a whole pipework has to be installed within the building. Again, that brings a lot of limitations to this type of building and this example, because of the reduced head height, because of the quite compact rooms that we have. Quite an intensive design has to go into installing these. But we did analyse it. We did mention it in the report as we'll say, a requirement of Passivhaus and one of the alternatives. And there's different criteria that have to be met in order to install it. Looking at alternative sources of energy, in most cases, and the more traditional add-on in this case would be the use of solar panels, both for solar thermal and water heating, and also to produce electricity. Most of the times that electricity is used for appliances, or to power partially or some elements of the MVHR system. In this case, we did analyse the buildings adjacent to this case study in order to look at a solar shading study. So we did a very simple study trying to simulate the height and the different elements on the neighbourly buildings. For example, on one side of the house, there's quite a higher roof that really casts quite a big shadow on this building, and also the dormer itself casts some shadowing, and then the adjacent building on the other side has a chimney stack that also has some implications on the roof. So really, the use of solar panels would not be very viable in this project. But the use of, for example, ground source heat pumps, the use of biomass, etc., could be implemented as a renewable as well. So that is also part of that could be suggested in terms of fulfilling the Passivhaus standard. So really looking now to conclude on what the report looked at, and as I've mentioned before, really this was the planning stage and evaluating the building on its potential of applying this standard. There's obviously lots of elements that I probably missed and not mentioned in this space of time. But just by looking at the fabric itself and enhancing that and creating that design implication and lowering that, well, increasing the thermal performance of these buildings can be quite a big task. I mean, we did look at all the alternatives of the Passivhaus criteria. The part of the report also was to point out all the paperwork that needs to be done, all the pre-planning, all the different elements that have to be met, the whole Passivhaus planning package as well, and obviously elements that need to be used to fill that and take on the design stage of it. So really, this report was really to set the scene on whether this standard was good enough for this building. The evaluation really brings a lot of question marks on the actual building size, limitations again as mentioned on the floor, limitations on the use of renewables. So it really has a lot of problems in order to fulfil the Passivhaus standard and the retrofit. The kind of preferred path would really be trying and to meet as much as possible these quite strict and adequate, really in some cases, standards on fabric as much as possible. But also touch on other elements that sometimes the Passivhaus misses. For example, environmental aspects, the sourcing of these materials. So looking also at the historical part of the building, how to implement other materials, and not just focusing on U values, not just focusing on numbers that Passivhaus tends to do, and also looking at a more user-friendly approach onto the retrofit of these buildings. So really that's kind of part of the conclusion, and quite important. I mean, just as a comparison of the two and some of the results compared with the current state and the U values, I mean, most of the alternatives do look and achieve the criteria. And some of them are kind of on the boundary. Obviously, the floor quite difficult to upgrade. Windows can easily be upgraded, as well as doors. But it's just how well and how cost effective it can be to really apply the standard. Really poses that question mark. So really, it's this whole idea of maybe applying the principles of Passivhaus, but also looking at other ecological elements, looking at the embodied energy of materials that we recommend, looking at the toxicity and the type of materials that are being implemented, not just U values, not just space heating requirements, but obviously branching out into other environmental impact criteria. And I think I'll pass over to John really to give his conclusions on the whole project.
Okay, thank you, Julio. Well, I would conclude and sum up on that technical demonstration that Julio has given, that from our perspective, we're creating a product, and we already are using the technical requirements in a creative way to enhance our eventual finished products. And I'd give you a number of examples where we'll do this. It's turning the constraints into our advantage. For example, we've already made the decision that we'll build an extension on the rear, because that will give us more space, but it will also enable us to achieve potentially the Passivhaus certification in a largely existing building. We will use some old techniques which have been dispensed with and bring them back on board. For example, it's not actually mentioned in the course of this discussion, but traditional Scottish houses always had, as a general rule, internal timber window shutters inside the glazing. These went out of fashion often and were removed and replaced with plasterboard linings. We intend to bring them back in again, but this time, instead of being a simple, fairly thin timber panel, we will make them they will look like a traditional panel, but they'll actually be a sandwich construction with an insulation material contained within. And that will be in addition to triple glazing, which will also ultimately reflect traditional sash and case windows in all likelihood. So it's very much it's being creative, but also we have to be economically aware, because it is a product and it will be either for sale or for rent. So we have to be realistic in that. But again, as a clear example of how we can turn that to advantage, in the holiday home sector, which we're involved in part, not solely, but in part, and this will be a holiday home more than likely, the energy cost on a weekly basis is about 10% of the rental cost. That's partly because holiday tenants tend to disregard energy because it's part of the package. So they're not energy conscious, it's all there, lights are turned on, heating's turned on. They're more inclined to open the windows than to turn the heating down. That's from experience. So we reckon we can reduce the energy requirement from 10% to between 1 and 2%. That, in monetary terms, can be translated from approximately, in the colder parts of the year, 100 euros a week down to towards 10 to 20 euros per week. That adds up, and that is part of the servicing cost of the building. There would be a similar factor if it was traditional housing, not quite as extreme, but the principle would be the same. So I think I simply sum up that we see the advantages in creating a better product that has a better value, and the end user gets all-round benefits in commodity and experience at the end of the day.
Okay, thank you very much, Julia and John. And we already have some questions from our online viewers. So let's start. The first question is from Tony Borkovic of EIHP. Has the airtightness been measured prior to reconstruction?
No, it hasn't. I mean, this was mainly a desktop and kind of analysis and work. Work on site wasn't done. I mean, we did visit the building several times, and we did get a lot of benchmarks on current sandstone and typical dwelling airtightness. And I did mention they oscillate between 16 and 20 meters cubed in terms of the airtightness. So.
Our next question is from Anne West of Fleming Muir Architects. Is there allowance for ventilation within the roof space, and has this been factored into the U value calculations?
At present, it does have some allowance for ventilation. I mean, the U value calculations that we performed, both pre and any assumptions and alternatives, I mean, they do account in ventilation within the voids, slightly ventilated, but not in a kind of more practical way. It's very kind of calculated. So yes, but not as a real situation.
Another question related to roof from Stuart Curry of West Lothian Council. Is the roof felt underlay being changed to allow an unvented roof? There also can be issues probably with use of kilt type insulation on sloping roofs as they sag through time.
That's true. Yeah. I mean, the way that we would really deal with the insulation in those areas in the roof would be try to obtain as much as possible a full fill of insulation and look at obviously the alternatives and trying to avoid that sagging really, which can be a big problem. So yes, I mean that's something that was considered in the report.
Then a question from Graham Drummond of Passivhaus Associates. Did you consider digging up the existing ground floor and laying a new concrete floor with insulation under the slab and around the perimeter?
That was an alternative, although given the kind of constraints in terms of cost and actually doing that and dealing with the different levels, I mean that is a viable solution, but I think cost-wise that would be quite an extreme and alternative.
There is if I can come in here, there is a possibility to put a thin insulant layer under floorboards on top of the solid floor. That would then be combined with, to gain effective head height given the low ceilings, would be to expose the timber floor stroke ceiling joists, which would create the effect of more height at the cost of sound insulation between the floors. And I think probably we would go for the former and accept that on a holiday basis the sound insulation isn't such an important requirement because people are more forgiving in that sort of holiday environment.
A question from Anne West of Fleming Muir Architects. Could solar panels not have been deployed via an external array rather than on the roof?
Well, I think if I can come in on that one, I mentioned at the beginning of my introduction that we've seen specified, I actually saw an example of it at the recent EcoBuild exhibition in London, a solar panel greenhouse. And here we actually have a very steeply sloping site, and you wouldn't have to go too far back into the site to get effectively an elevation that would give sufficient sunlight coming over the top of the roof line of the house. And there were some interesting adjuncts to it also, in that there is apparently now the development of two-way solar glass that you can get the sun coming in from the backside, as it were. So as the sun moves around, you get an extra benefit. So that's certainly a neat way, we think, of providing PV in the garden. We've not done the sums and the calculations to see how much it can provide, but certainly looking at the built example in the exhibition, it looked at least the equivalent of what you might expect to get on a roof. So that is definitely under consideration now.
A question from Michael Hodgkinson. Would it not have been possible to use vertical insulation around the floor?
Does you mean kind of thin insulation, I guess?
It's not
around
absolutely clear around the floor. Maybe he will.
If it means on the floor,
yes.
It's the sort of insulation. If it's the sort of space age type insulation that comes in a very thin but multi-layered construction, then that would be possible underneath an engineered timber floor.
Mm-hmm. The problem there is even if it's very thin, it does require around 20 millimeters. So that's really taking us below 2 meters if we do apply something like that. But obviously it's a question of calculating different heights and seeing what the minimum would be.
Mm-hmm. A question from Peter Doherty of Doherty Consulting Ltd. Do you have indicative costs against each measure?
No, we didn't go that far into the analysis.
Again from Anne West of Fleming Muir Architects. Retrofits within Europe have featured the use of external insulation systems. Was this considered?
No, mainly because the building is situated within a conservation area, and although what we can see in the front elevation is quite recent, that was pre-conservation area and different guidelines. So really, the context of the different buildings around it would not really adapt to external insulation.
A question from Martin Jarvie of KLM Partnership. Was a CO2 reduction as an outcome of the work done ever calculated or estimated?
That would be really part of the Passivhaus planning package, and with a bit more detail into the U values that were calculated, and really looking at a heat loss calculation within that spreadsheet. So not at this stage, but definitely that would be the next stage to really apply those ideas into the spreadsheet and looking at heat loss.
Michael Hodgkinson is adding a further explanation of his previous question. No, he's thinking about taking insulation down the wall in the subfloor to insulate the ground trapped.
Yeah, underneath. Yeah. Well, I mean, that's a good suggestion. It would really have to be looked at in terms of the construction capabilities and whether it's viable to dig and to reach those areas.
If I can also come in, that at this stage, the next stage for us is actually to start doing some more live poking and digging, because we haven't exposed certain areas, so there's some unknowns. But as we build up the specification to the eventual final specification, as it were, then there will be further work done on that. And looking at the floor, given we've got a very restricted floor-to-ceiling height at the ground level, it's not out of the question that we might actually drop the floor and just dig out what's there, because it's not a big house, therefore the floor area isn't huge. It's just an economic factor that has to be taken into account. But again, as there would actually be a design benefit in that we'd improve the floor-to-ceiling height, it might be viable to do that. And in which case, of course, we could put insulation either underneath the new ground floor construction, or above, as the case may be.
So would you say that Passivhaus standards really put a lot of constraints on small traditional properties, but that they might be more acceptable on larger properties?
I think that's very much the case. Yes. Larger properties where you've got the space, to some extent, to be much more straightforward. Here, the way around it is effectively because we can build an extension. Therefore, the north-facing rear wall becomes an internal wall entirely in our minds, and therefore the new construction can be designed to new build passive house construction. There are other considerations which are worth flagging up in older or historic buildings, which haven't been mentioned here because they're not an issue. But for example, if you have traditional features such as cornices at ceiling level, that creates another problem if you're adding thickness. That one we haven't really cracked yet, but we're thinking about it because it really means you can only use thin insulation in dimensional thickness terms if you want to not have to take off cornices and move them in, fiddle about, which would be damaging to the authenticity of the property and expensive. But here, all the cornice work, such as might have been, has already been removed and replaced by unsatisfactory modern construction in this case. And therefore, we can strip it out and not have to worry about that.
There are no other questions from online viewers. Do you have any other messages or comments that you would like to give, lessons learned through this process, through this study, or maybe the next steps that you would undertake to on this project or similar projects?
Well, I think from our point of view, the next step is to build up an agreed specification and cost it out, because obviously the cost is a major factor. But as I've already illustrated, wherever possible, we will try and use it to gain benefit and not just see it as a cost, and hopefully get the balance right at the end of the day.
Here is a question from Stuart Curry of West Lothian Council. Is there a move away from the use of phenolic polyurethane and EPS, especially if space is tight?
Yeah, I mean, that's why we looked at two alternatives, and that's where the use of wood fibre, and sheep's wool was kind of another alternative. And it proves to be maybe slightly thicker, minimal, but very close kind of U values and just as good performance. So yes, there's definitely other alternatives, and a lot of the case studies that we looked at other retrofit buildings using Passivhaus, especially down in England, Victorian buildings, etc., did look at more environmental materials. So we really just wanted to show the two different alternatives, the two uses of materials.
Okay, well, thank you very much. I would like to thank you at the end of this webinar. There are no additional questions from our online viewers. And I would now like to attract attention of our online viewers to our forthcoming events. The next webinar will take place on 2nd of May. The title is Life Cycle Costing of Novel Board Material. And this is a study undertaken here at Glasgow Caledonian University in collaboration with Dunkrine Ltd. And then the following day, on Thursday, 3rd of May, there will be a webinar on retrofit solar PV for housing, case studies from 3 housing associations. Now, again, they will be presented by Julio Bros Williamson of Edinburgh Napier University. So we look forward to welcoming you at our forthcoming events, and I would like to thank you again for watching today's webinar. Thank you.